Hi guys, today we are going to be talking about conic sections. But the quick question is, what is a conic section? Conic section is the intersection between a cone and a plane. So cone, back in the day we love ice cream. What do I mean back in the day? It's like right now. I sure could use a cone. Yeah. So a conic section is the intersection. We may have a circle, parabola, ellipse, or hyperbola. We're going to spread and we will table parabolas, ellipses, and hyperbolas. So we're going to dedicate one video to each type of conic section. So let's go ahead and look at a circle. So circles, what are they? Nice and round objects. Formal definition is a circle is a set of points in a plane that are equidistant from a fixed point where I'll talk to you about this in a bit. So the fixed point that is called the center, the fixed distance it is called the radius. So we're going to take this fixed distance, circle it all the way around, and we get this pretty cool shape or a circle. So let's go ahead and start with fun problem number 1. So it reads, graph the circle with center 1, 2, and radius 3. The first question that I get asked is, do we need to find the equation of a circle? I mean, if you're an overachiever, go for it, but it's not needed. To graph a circle, we just need a couple of pieces of information. One, we need the center, and then two, we need to know what the radius is. So let me go ahead, try to zoom this in. I'm still new to this, believe it or not, so let me play with this. Oh, no. Okay, yeah, there you go. Oh, I'm not nervous. You're nervous. All right, cool. So let's do this. So the information, what was that? The center, I'm trying to copy it. The center was 1, 2, and then the radius was 3. Okay, fantastic. Okay, so to graph a circle, let's begin by graphing the center, which is 1, 2. So from the origin, we go 1 to the right and 2 units up. Let me go ahead and do a point. And then we're going to locate a few points that are 3 units away from the center. So the radius is 3. From the center, let's go 3 right, 3 left, 3 up, and 3 down. So 3 right, 1, 2, 3. Hopefully I know how to count. Let's come back home. 3 to the other side, 1, 2, 3. Let's come back home. 3 up, 1, 2, 3. Cool. And then come back home. 3 down, 1, 2, 3. Cool. One of the questions that I get is, can we go along the diagonal? So 1, 2, 3. And the answer is no. Oh, I was supposed to tell you no why later, but I forget. The reason why we don't go on a diagonal is because the unit is actually not 3. Why not? It comes from the Pythagorean theorem. So let me go ahead and do a square right here, which will represent my graph paper. So we say that the unit is 1, whether we go to the right or whether we go sideways or up or down. So if we go sideways, the unit is 1. If we go up or down, the unit is 1. But now the question is, what is that distance when we go on a diagonal? When we think about the Pythagorean theorem, when we do the math, we realize that the distance along the diagonal is not 1, but it's actually the square root of 2. So this is why we never go along the diagonal. So just think about a map, north, south, east, west. Which one's east, west? We. Okay, west, e. We don't say you, we say we. Okay, so to graph a circle, we identify the center, and then we find 4 points. Ignore that. How can I erase it? Let me try to do that in a bit. Okay, so let me go ahead and erase it. 1, 2, 3. Sorry, speaking to myself. Okay, so to graph the circle, we're going to do our best and connect these 4 points, trying to do it as round as possible. Oh, that's not good. Oh, that is terrible. One of the questions that I get is this, go for it. But for me, what I'm more concerned is, did you locate the center? This is getting worse by the second. What I'm more concerned is, did you identify the center? And then did you locate 4 points? And then you're just gonna do your best to do a nice circle. Do I have to do it round and round? As a student, do we have to go round and round? No, I'm just trying to spare time as I'm trying to say my speech. But yeah, that was terrible. Remind me never to do this again. I'm just gonna do it once. I'll try my best. If it looks good, cool. And if it doesn't, then it doesn't. Okay, so give me a second. I'm gonna go ahead get my document camera, and then we'll actually do these by hand. Not by hand, but with my with my pencil. So I have a fighting chance to make it look a little bit nicer. Give me a sec. Okay guys, I think I milked fun problem number 1 as much as I could. I tried to redeem myself by graphing it by hand, but as you can see that didn't look nice. The only thing that I changed, well, I don't want to say I changed, the only thing I added was I labeled the coordinates of the 4 points that we explicitly graphed, the one where we put points. Hopefully that will make up for a less than perfect circle. Okay, so let's go ahead and do this. So we have 2 more problems to do and then we're good to go. Before we do our second and almost final fun problem, let's go ahead and look at the standard equation of a circle. Okay, an equation is said to be in standard form if it's written of the form square of x minus h plus square of y minus k is equal to r squared. This is also known as center radius form. The reason why it's known as center radius form is because if we have the equation in this form, then we should be able to quickly identify the center and the radius. So the center is given by hk. To identify h, we have to see what's after the first minus sign to identify what is r. So r is our radius. So whatever the base is, that's going to be the radius. So let's go ahead and look at fun problem number 2. So the directions read graph the circle. Well, that's nice that they told us what the conic section is. Graph the circle, identify the center and radius. So the difference between fun problem 1 and 2 is that in 1 they explicitly told us what the center was and the radius. This time around they gave us the equation and we have to deduce what the center and radius is. So it would be nice if this equation is in center radius form. So we have square of x minus h plus square of y minus k is equal to radius squared. So let's go ahead and make sure it looks exactly like this. So we want x minus a number. So we're going to force that addition problem as a subtraction problem. You know, someone said subtraction is the same as addition of the opposite. Okay, so subtracting negative 4 is the same as adding 4, but it's just a little bit easier for me to see what the value of h is. Let's go ahead and write another subtraction problem. So we're going to add to it the square of y plus 2, which you will write as y minus negative 2. So again, subtracting negative 2 is the same as adding 2. And we want to write 16 as a perfect square. In English, we want to write it as the square of something. 16 is a perfect square because it is the square of 4. So we're going to write 16 as the square of 4. Now, for the grand finale, what is the center? What is the radius? So the center is given by hk and the radius is the base of the constant term. So the question is, what is h? What is k? So h is the number that follows the subtraction sign on the square of the binomial with the x. In this case, we're subtracting negative 4, so h is negative 4. What is the value of k? So k is that second number that follows the subtraction sign. The number that follows the subtraction sign is negative 2, so that will give us a k of negative 2. So the moral of the story is that the center is given by hk or negative 4, negative 2. Fantastic. So we are asked to graph this bad boy and we are asked to identify the center and radius. The center is nailed. The radius, what is that? So in this case, the base is 4. So that means that the radius is 4. I mean, a different way you can go about it, I don't like to do this with my students, but if you like it, then I like it. Okay, so we have that the constant term equals r squared. So you say constant term equals r squared and you square root both sides and that will give you r equals 4. So we ignore the negative root because length is non-negative. So you do it however you like. For me, it's just easier to write 16 as a perfect square. So that way I can see like, okay, what's the base? Base is 4. Okay, r is 4 or radius is 4. So let's go ahead and graph this circle. So our starting point is the center, negative 4, negative 2. So from the origin, we go 4 left and 2 down. The radius is 4, so let's go ahead and identify 4 points. Let's go ahead and identify some points that are 4 units away from the center. So think about a map. Remember, up, down, side to side. So we're going to go up 4, 1, 2, 3, 4. Hopefully I know how to count. Down 4, 1, 2, 3, 4. Left and right, 1, 2, 3, 4. 1, 2, 3, 4. I should have my kids count with me. Okay, cool. So we're gonna do our best to connect all these 4 points, making it look kind of like a circle. So let me go ahead and do this. No pressure. Okay, so I'm improving. Is it a perfect circle? No, I tried my best. Nowhere in the directions does it say that I have to label these points that I graphed at the end, but I'm going to do it for fake extra credit. So we have 0, -2, which is this -4, -4, -6. This one should be -4, 2, and this one should be something -2. -8, -2. So that way, if my circle is less than perfect, it will be easier for the grader to read, but this is totally optional. Okay guys, so for the circle unit, we are gonna do a total of 3 problems. This is the second problem. Let's go ahead and do the third problem. Okay, so fun problem number 3, always making it a little bit spicier as we go along. So the directions read, complete the square to find the center and radius of the following circle, then graph the circle. So we need to pay special attention to the directions. You can have a really beautiful circle, but if we fail to follow the directions, then it's not possible for us to get full credit. So we have to complete the square to find the center and the radius, and then we graph it. So this second variable, I'm going to pretend like it's not there. Okay. So let's just say that the problem said solve the equation by completing the square. So when we were solving for x back in the day, we had said, okay, our first goal, isolate the constant term. So in this case, we will move the 15. Now, just because we have 2 variables, it doesn't mean that the rules change. Okay, so to complete the square, you want to isolate the constant term. So in semi-English, so we'll subtract 15 from both sides, and that will give us x squared minus 6x. We want to group the x's together. We want to group the y's together. And then we're going to put a reservation to complete the square. So we want to complete the square for the x's. So I'm going to say plus something. Bring down the rest of the problem. Y squared is positive, so plus y squared. 8y is positive as well. And then these cancel out, and again we want to complete the square not only for the x part but also for the y part. So let me go ahead and put a reservation plus a beautiful number equals, on the right side, sum of -6 and -15 is -1. Take it right there. Okay, sorry about that. I was trying to play with the lighting situation. So where were we? We are trying to complete the square to find the center and radius of the following circle. So how much work should you show me when you complete the square? That is a personal choice. I'm going to try to show everything. Okay, so to complete the square, we're going to take the coefficient of the x term, or the degree 1 term. Let me go ahead and remind myself. So 1, we're going to identify b. So b is the coefficient of the degree 1 term, or the x term. So b is -6. And then 2, we're going to multiply it by 1/2. So again, most books, if not all books, will say divided by 2. It's going to be the same difference. So to complete the square, 1, we identify b. 2, multiply it by 1/2. 3, we're going to square the result. And then 4, we're going to add the result. Okay, so in this case, to complete the square for the x part, because we're going to have to repeat for the y part, we're going to go ahead and add 9 to both sides. So why? Because that's one of our properties of equality. You know, what we do to one side, we got to balance it off and do it to the other side. Now let's go ahead and complete the square for the y part. So same speech. 1, we're going to identify b. So b is the coefficient of the degree 1 term. In this case, it's 8. 2, we're going to multiply it by 1/2, or divide by 2. Same difference. 3, we're going to square the result. And then 4, we're going to add the result. So in this case, to complete, yeah, you cannot see that, sorry. From the top, 1, identify b, done. 2, multiplied by 1/2, that gives us 4. 3, let's go ahead, square the result, that will give us 16. And then 4, we're going to add the result. So remember, this is an equation, so what we do to one side, you got to balance it up and do it to the other. Depending on how cool you feel with comforting, you may write this as a perfect square. I want to be surprised. Well, I'm going to pretend I want to be surprised, so let's do this. So in this case, this will factor to x minus 3 times x minus 3. And then for the y's, that will factor to y plus 4 times y plus 4. Again, if you're having a moment, go ahead, look at your work. Whatever half of b is, that's going to be your secret weapon, your secret sauce. 1/2 times b is -3, so that's what goes in the parentheses, or you can generally factor. You know what goes in the parentheses? Whatever 1/2 times b is. 1/2 times b is 4, +4, that's what goes in the parentheses, or you could generally do the math. Okay, so we keep our cool. Sum of this, I don't know, I'm going to just add these two. So that will give us 25 minus 21 is 4. Cool, fantastic. So again, it is no surprise that the binomials are the same. Why is it not a surprise? We wanted to complete the square, so we wanted to have a perfect square, and we do. Okay, so to answer the question, complete the square to find the center and radius of the following circle. Okay, we completed the square. We don't have to box this, but for some reason my eyes just want to. Okay, so we completed the square. Cool. Now let's go ahead and identify the center and radius. If you see the center and radius, be my guest, write it out. But I generally don't. So let me go ahead and write the center radius form of a circle. So a circle is said to be in a circle is said to be in center radius form if it looks like this. Square of x minus h plus square of y minus k is equal to radius squared. So let me go ahead and write down our equation over so I can tag it up, making sure I have minuses. We're going to go ahead and write the +4 as a -4. So subtraction is the same as adding the opposite. And we're going to write that constant term as the square of something, or the square of 2. So with that being said, what is my center? My center is given by hk. In this case, the value of h is 3 and the value of k is -4. So remember, to identify h and k, we look at the numbers that follow the subtraction sign. So in this case, h is 3. So our center is 3 comma something, and k is -4. So our center is given by 3, -4. I don't like the look of this. The uppercase C and the parentheses look identical. So let me just write center equals 3, -4. Now the question is, what is the radius? The radius is the base of that constant term. So in this case, the base is 2, so the radius is 2. Fantastic. So we completed the square and then we identify the center and radius. What we have left to get our perfect A is to actually graph the circle. So we're going to start off by locating the center, which is given by 3, -4. So from the origin, we're going to go 3 right and 4 down. And then we are going to locate a few points that are 2 units away from the center. So the radius is 2. So let's go ahead, graph those bad boys. So we're going to map it, north, south, east, west, up 2, down 2, left 2, right 2. So up 2, let me go ahead and label it. This will be 3, -2, down 2. It will be 3, -6. 2 right, 1, 2. That will give us 5, -4, and then 2 left. That will give us, what is that? 1, -4. Cool, fantastic. So let me go ahead and zoom in for dramatic effect, and then I'm going to do my best to connect all 4 points, and hopefully it looks like a circle. Okay, I tried my best. I think that's the best circle yet. Cool. Okay guys, that's my time. In the next video, we're going to talk about parabolas. Thanks.